Hi guys, welcome to this quick recording on how to use Excel basically and also Google Docs and to plot data. For this purpose, basically what I have in here, I have some data from one of the labs, and this data is actually for a projectile motion. So it doesn't matter really what this data is coming from, but just to give you an explanation where this data is coming from. So you have a height in here for a projectile, you change the height, you throw it from a lower height, from a little bit higher, and so on and so forth. As you throw it, as you let go of the marble will fall at different distances from your input, namely called the range. So you'll have different ranges, and the data in here is already converted to meters. The measurements are actually in centimeters. So this is 45 centimeter, this is 51 centimeter, 39 centimeter, 32 centimeter, and this is 60 centimeters. So, and then the heights are actually also in centimeters. This is 110 centimeters, 130 centimeters, 75 centimeters, 50 centimeters, and 175 centimeters. In the actual plot in here, we really don't need the range. We need the square of the range. That's why we have it. This numbers in here are the square of this one. So 0.45, if you square it, you're going to find 0.2025 and so on and so forth. So these are the squares of that. So actually what I'm trying to plot in here, I'm trying to plot the square of the range as a function of h, the height. That's why I need to put them next to one another, because it's easy for me to grab. So whenever you're trying to plot something, and depends on the other one. So this will be my x variable, namely independent variable, and this would be my y variable, which is my dependent variable. So always put the independent variable or the x values on first, and then your dependent variable, in this case the y values, next to them, because it's much easier for you to grab them using your mouse. Otherwise, it's hard to find them using something else to insert them. I mean, there is another way of doing it, but that's fine. The easiest way is to put them one next to one another. First one is the x values, second one is the y values, and you plot them. So what you do in Excel, you go in here and insert, and you're going to change the scatter, and automatically gives you properly the y values on the y-axis, and it's properly scaled from 0 all the way to 0.4, because this data in here, the square of the range, changes from 0.1 all the way to 0.36. Okay, so Excel was smart enough and tells you, okay, I'm going to put the data in here, squeeze it between 0 and 0.4. It manages to get all of your data in that range. Sometimes you don't like the default the way that it does, but the default in this case is very good. Uh, for the height, which is my independent variable, that's what I was changing, by the way. I was changing the height. And then with it, the range was changing. In other words, the square of the range also was changing. So again, it varies from 0.5 all the way to 1.75. So Excel was smart enough to say, you know what, I'm going to put it between 0 and 2, and that's 0 and 2 meters. Okay, so now we have my data plotted as it should be. But usually I need the trend line. I need basically the equation, because I need the slope. For the case of the lab for Physics 101, the first lab, we're doing the speed of sound. So we plot in that case the wavelength as my independent variable. So we were, I'm sorry, yeah, my wavelength is the y-axis. So I need the y-axis in here, okay? And for the x-axis, I need the frequency, because the frequency is given. But I can't really honestly plot the frequency itself, so I need the inverse of the frequency. So in that case, what I would do is put the frequency in here and invert it in here, okay? So the inverse of the frequency will go in the x-axis, and the wavelength will go in the y-axis, similar to this one. So all I have to do is prepare my data first. So my independent variable in that case will be the frequency, because that is the one I was changing. So the frequency will go in here. But since I'm not plotting really the frequency, I'm plotting the inverse of the frequency. So I need to put the inverse of the frequency instead of the x-axis, because I want it to be on the horizontal axis. And then in that case, I want to plot the wavelength. The wavelength is my dependent variable. It changes with the inverse of the frequency. So I'm going to put it in here. If I do that, the slope will be exactly the speed of sound. Okay. So in this case, again, I'm going to go in here, go to trend line, and give me a linear equation because I prepared my data correctly. So I'm getting a line. And usually I need the more options to get into the trend line. Okay, more options to get into the equation, and also I need the R squared. These two values are sometimes very useful. Let me explain what they are. The equation itself has the slope in it. So the slope is the coefficient of the independent variable. Coefficient of x is your slope. So in this case, 0.2045, that's the slope. And there is a y-intercept. Technically, it should be a line that passes by the origin, but it's not because there is an error. So this is not exactly 100% a line because the R squared in here, the regression, it's telling me how accurate this is from a line, and it's 99.01%. That's good, okay? This is a very good approximation. So this is basically what I'm finding in here. So another way of finding the slope, I could come in here and say slope and come in here and write equal. It's important whenever you're writing formulas in Excel is to put the equal sign and put slope. The formula in this case is a function, and the function in this case is a slope. And it takes as the first argument the y variable, the y data from B2 through to B6. And the known x values as a second argument, basically the independent variable, and then close the parentheses. So Excel was able to give me the slope, which is approximate to 0.2045, and in here it was actually able to go far more digits. You have to be careful when you're reporting data in any lab. Do not put more precision than when you actually have collected. I was doing measurements, for example, 45 centimeters, so that's the best I could do, is to get 2 sig figs. So technically this is not correct. I mean, to keep retain so many sig figs in here, okay? But that is how you find your slope. That is how you find you graph data using Excel. So let's do the same thing now with Google Docs. So let's put Google Docs. Google Docs is a little bit tricky, honestly, and you have to really make sure you know your way through it. So I'm going to do the same thing, select the beginning and the ending of the cells, and I'm going to go in here and say insert to chart. So if I click that, so let me get rid of this first and make this one a little bit smaller so that they can see the whole thing and move it inside. It gave me a bar graph. That's not really what I want. I want this one to be my x-axis, and I want this one to be my y-axis. So we're going to come in here and change the style of this graph and go to the series. I'm sorry, to chart first of all. What is it? The setup. Okay, the setup. Make sure you are in the setup. I'm sorry. Okay, make sure you are in the setup, and it needs an x-axis. The x-axis is actually the H values. That's my x-axis, okay? And we need to change this one actually from this bar graph to a scatter data, okay? So that's one thing. And it still doesn't look too good because I still have the x-axis being the H, but I still have the y-axis being both the H and the square of the range squared. So I'm going to remove this, and that's it. So now I have my graph the way it's supposed to be, similar to Excel. Okay, another way of doing this is actually finding the legend. So I'm going to go into, I'm sorry, finding the trend line. So you have to go into, again, the format. Once you get into the series, you're going to go to the trend line. And in the trend line, make sure you use the equation and show the R squared. Both of them are giving me the same result as before, except Excel was a little bit less precise in this case, but don't be fooled. Also, you could get the same precision, as much precision as your actual precision should be. So I'm going to close this window in here. I'm going to come in here and show you that indeed it's the case. So the same function slope also exists in Google Docs. So you put the equal sign again, then you put the slope function, and you tell it also my data values are this ones, and my x values are actually the other one, which is from A2 all the way to A6. So I'm going to enter it manually from A2 colon A6. Oops, A6. Okay, make sure you enter everything correctly. And when you do, you hit enter, and the value is again as precise as I was saying as Excel. So it's going to give you the same value, 0.2045. So this function in here and the way that you have it in here represented sometimes can be a little bit tricky. But this too also shows that it is not an exact, how should I put it, a linear function, because there is a y-intercept, and the y-intercept is negative 5.49 times 10 to the negative 3. That means 0.00549. And again, the regression in this case is telling you how close you are from a line, and it's 99% accurate. So that's good. Okay. So the main point in here, how to graph a data set like we have in here. Okay. So what we did in this lab in here, we measured h, the height, we measured the range. We don't need the range, we need the square of the range. So we square these numbers and we put them in here next to my x values. And then we select them and insert the graph in the case of a scatter graph in the case of Excel. And in the case of Google Docs, also you could work your way back to a scatter graph, and you also can show the function, the trend line, and you also can find the slope. Now, you have to be careful with your data. You have to prepare it. In this case, I already squared these numbers. If I don't, the function actually in this case will be a parabola. So the trend line should not match a line, it should match another quadratic function. The same thing with the Google Docs also. You have to be careful, you prepare your data. For the case of our lab, the first lab in Physics 101, it deals with the speed of sound. So in that case, we collect different wavelengths using the resonance and for different frequencies. So what I'm changing in that case are the frequencies. That is my independent variable. What is being affected in this case, the dependent variable, are the wavelengths. If I'm careful enough with that experiment and plot the wavelength as a function of the inverse of the frequency, not the frequency, the inverse of the frequency, I will find the line, and the slope of that line should be the speed of sound. Now, if I'm not careful enough and just wanted to draw the wavelength as a function of the frequency, it's going to be a function that drops like 1 over x, basically. Okay. So that's not the same thing. You could still get some information, useful information off of that, but it's much easier to draw it when it's a linear like this one. Okay, I hope that this recording is useful for you guys. And if you have any questions, please let me know. And if you need more help with these things, please let me know. Thank you.